This is going to be a quick lesson or a quick introduction on a new topic looking at nonlinear relations. And this nonlinear relation is going to be focusing on quadratic relations. So we're not going to talk too much about quadratics right now, but in our next lesson we will. This is just going to be an introduction to get us to think about relationships between variables being nonlinear. So when we're looking at a relationship, we should be looking at an independent and a dependent variable. So when we're looking at an independent and dependent variable, right, we want to identify which one is which. So an independent variable is the one that you control before the trial begins. And then a dependent variable is the one that you measure during the trial. This is affected by the independent variable. So we want to think about tracking the height of a basketball shot. What are the two variables involved in this? And of those two, which is the independent and which is the dependent? So if we're thinking about tracking the height of a basketball shot, one variable will be the height of the ball. Now the other variable could be one of two things, right? There might be more, but when we're looking at the height of a basketball shot, something that we might be looking at might be the time since the ball was shot. The time since the ball was shot, we might think of if one variable is looking at the height or the vertical distance of the ball, the other one might be looking at the horizontal distance of the ball, right? So we'll just look at these two for the sake of this kind of introduction, and which one is going to be the independent and which one is going to be the dependent. Well, because we've looked at time is an easy one. Time is generally always the independent variable. Right? Nothing is real. Time is not affected by anything. Time just exists as is. It doesn't get affected. Time doesn't slow or speed up. Right? Our perception of it might, but time runs at a consistent pace. Right? So time is always going to be independent. The height of the ball would then be dependent. Right? How high the ball is dependent on when or how long it's been since the ball was shot. Right? If it's a long time since the ball was shot, chances are it's probably on the ground. Right? If it's just shortly after it's shot, it's probably just leaving our hands. And then maybe somewhere in the middle is when we have the ball at its maximum height, right, in the air. Right? So we have the height of the ball being our dependent. We have the time since shot or since the ball was shot being our independent. Now, with a nonlinear relationship, we have what is called a curve of best fit. Now, a curve of best fit is very similar to a line, and it is a smooth curve drawn to approximate the general trend or path in a scatter plot. And the key thing here is that this is not always a straight line. Right? We've looked at relationships where it is a straight line, but in this case, it's not always going to be a straight line. Because not every relationship is going to be a linear one. Right? We could have relationships that are non-linear. So what you're going to do is you're going to, and we did this investigation in class, you're going to measure and record the length of group members or other students. You're going to measure their thumb length, and then you're going to measure and record the length and width of their palm to calculate the approximate area. And try to get enough data points, a minimum of 15, and draw a curve of best fit. We want to identify the independent and dependent variables. Now, in some cases, it might be hard to think about, okay, well, what's the independent and what's the dependent? But you would have to kind of think of it as which variable is affecting or causing a change in the other. Right? If it's causing a change, then it's most likely going to be the independent. If it's being affected or it's being changed by the other variable, it's going to be the dependent. That is going to depend on the one variable. Now, in this case, right, it's like what really affects the other? Does the palm length cause or affect the thumb length, or is it the length of your thumb that affects or determines what your palm area is? Right, so it's a little bit maybe harder to think about in this case, but because we have our tables already kind of labeled, generally speaking, the first column or the X variable is our independent and our Y variable is our dependent. So that's a good general rule of thumb to think of as well. All right, so you're going to go through, you're going to collect data, you're going to plot this data into a scatter plot. Again, palm area on the Y and thumb length on the X, right? Ideally, when you do this, you would want to get a wide range of age groups involved because if you're collecting data from a lot of similar people or people of a similar age, you might think that the hand size is probably or generally going to be the same, right? If you have different age groups, you're going to have different sizes of students, so that would probably give you a wider range of thumb lengths and areas. But either way, hopefully you should go through and find some data and come up with a relationship. So when we looked at it in class, again, we had some data that kind of indicated more of a linear relationship, but hopefully you find some data or you collect data that is nonlinear. Either way, you get what you get in terms of your data. Just make sure, at least we now consider that we might have to draw a curve of best fit, not necessarily a line of best fit.